邀请到2位演讲嘉宾，来自 Zeiss 的 Tamoy Kandu 先生以及 Clive Yan 先生，他们将为我们带来题为 Quality Innovation Across the AI Chip to Rack Stack 的精彩分享。For our next session, it is our great honor to welcome our speaker, two distinguished speakers from Zeiss, Mr. Tamoy Kandu, Global Head of Sales, Research Microscopy Solutions, and Mr. Clive Yan, Global Head of Electronics Customer Segment, Industrial Quality Solutions. They will share their insights in a session titled Quality Innovation Across the AI Chip-to-Rack Stack. Ladies and gentlemen, please welcome Mr. Tamoy Kandu and Mr. Clive Yan.
Close your eyes. What do you see? Do you see yourself? The path in front of you? The next step? Do you see your ambition? The cutting-edge approach that opens new dimensions in medicine? The biggest miniaturization that lays the foundation for the digital revolution? The holistic perspective that transforms humanity for good? The progressive vision that changes everything? The way you see the world, the way you capture moments, the way you transcend knowledge, the way you define precision and productivity, the way you live, move, love, heal, think, are. Open your eyes. Can you see it? Together, we are challenging the limits of imagination. Zeiss. Seeing beyond.
Good afternoon, everyone. I'd like to start by thanking our customers, partners, supporters, and all the media outlets who are here for this talk. So, Zeiss was the first quality innovation partner at Computex. So it's a great pleasure for us to talk about quality today, because quality matters, and we will show you why quality matters and how quality innovation is working from chip to the rack to enable AI. So today, we use AI every day. Millions of people use AI. We are using it day to day to answer our emails, do our work, create agents, create autonomous robots. Everywhere there is AI. But very less time we think about what is really powering this AI. AI is not just a software. AI is an infrastructure. And to do this, you need to have chip, systems, power, and cooling all working together. Behind this interface is the data center. Actually, there is no better place to learn about this than being here at Computex. You see the number of people, the number of customers, the number of vendors, the number of companies that actually are working together to enable AI in the modern age. So, data centers doesn't happen just like that. There are a lot of quality challenges that we face in data centers. Yeah, it starts from cooling. We heard a lot about cooling. It starts from connectors, optical interconnects, racks, thermal management, all the way to the heart of AI, which starts with the chip. So let me take you on a journey on what are some of the quality challenges that we see today, starting with the heart, that's the chip. So, chips today, the logic chips that powers AI, are manufactured by the most complex manufacturing process in the world. You don't believe me? Ask ChatGPT. Yeah? It is really the most complex manufacturing process known to man. The new M4 Max chip on the MacBook has more than 90 billion transistors. Let's take that in for a minute. 90 billion transistors in a chip that's the size of your fingertip. Just for context, there are 8.2 billion people in the world. This 90 billion transistors are made through the TSMC 3 nanometer technology. 3 nanometer, for context, is 30,000 times smaller than the width of your hair. This is the scale that we are talking about. This is the complexity that we're talking about. And complexity has a cost. And the cost can be staggering. So if you think about what TSMC invests to make this happen, last year, TSMC invested more than $38 billion in capex just in Taiwan. The largest single foreign direct investment in the US is by TSMC. It's 65 billion US dollars. This complexity needs billions and billions of dollars to make just AI happen. So the question becomes, how do you get return from such huge investment? And the answer is in one word. It's called yield. If you don't assure yield, you have billions of dollars in jeopardy. So how do you ensure yield? This happens through faster failure analysis, faster root cause analysis, and faster process optimization. And so everything that we talk about, I'm going to be talking about speed and throughput because that has a direct dollar value, and that value is in the billions. So let's start off with transistors. I spoke to you about the 90 billion transistors that are on the M4 Max chips. These are what I call the heart of the chip. These are what creates the zeros and ones that drives digitalization in the modern age. And these chips are 3 nanometer. What is 3 nanometer? Just a few atoms. So when you want to inspect this chip, you can only inspect it in what we call a transmission electron microscope. So you see this picture here. This is a picture of a transmission electron microscope to see this FinFET transistor. Now, you can't simply put in the chip. You have to create a thin slice to go in and inspect. We are talking about a 10 nanometer slice. In scale, probably that's 25,000 times smaller than the width of your hair. This is the kind of precision that we talk about. And you can only do this with what we call a focused ion beam or a cross beam. This is where in an electron microscope, you see the system and you use a gallium ion fib, which you can imagine like a very fine Japanese knife, right? To cut that slice. This requires highly advanced technology, highly advanced engineering, highly advanced system. And actually, the ZEISS system is trusted by the most advanced fabs in the world to be able to do this lamella. Now, just making this lamella or this thin sheet is not enough. What matters? Speed. I told you, throughput is what dictates the economics of your billions of dollars of investment. So getting this in an automated manner with the right throughput is what dictates whether the fab can be returning their investment and having the optimum yield. And that's exactly what our system is able to do. Let's go to what we call a DRAM. A DRAM have millions of cylindrical structures, and often you have to see the physical measurement of the structures. Imagine measuring this millions of structure in a manual process. This could take days. So again, what do you do to improve throughput? You actually take an image of the interface and you use an AI model to segment and to automate the metrology of these and measure these structures. This is possible with our new Blockwise platform, which drives automation with AI-enabled models. And this drives throughput. Next is packages. Now, your AI is not enabled by a single chip. Typically, there are multiple chips that are stacked with multiple interconnects and, or you could say wiring into a package that basically gives you the output. Now, this packages for scale, we are talking about 10 centimeters, 8 centimeters packages. But the defect that you want to see is in the order of nanometers. We often use the statement, finding needle in a haystack. I can tell you, that is an understatement, unless your haystack is the size of the world. Yeah? So this is the challenge that you have. How do you identify, isolate, and really evaluate a defect in a package as the packages are growing bigger and bigger because we want more AI power? So here we have solutions like correlative solutions where you do imaging, identify, localize an area, cut it, do image again, localize further to get this in, right? To find the defect. We do this through our X-ray systems and our crossbeam systems. In a very simple way, this is also what happens when you go to a doctor and say, hey, I'm not feeling well. Yeah? If the doctor said, hey, let's open you up and start looking for the defect, you would probably not allow it, right? So you go through various imaging to identify where exactly the defect is, and then allow the doctor to operate on that defect and identify. So these sort of correlative workflows in the nanoscale actually comes from the real world. It's very, very practical. And Zeiss is one of the only vendors that can allow you to have this multimodal correlative solution across multiple technologies. So this what creates is higher throughput, better quality, and obviously better yield. Now, the quality challenges just does not stop at the package level. It continues with PCBs as well. And for PCBs, I'd like to invite my colleague Clive on stage.
Thank you, everybody. PCB, who doesn't like PCB? If we talk about chip, it's the heart of the AI server. PCB is the body. Actually, they bring those very important data and signal to all the necessary nodes and make it functionalized. However, PCB is facing a super big technical challenge right now. If we were talking about the traditional consumer electronics, we talk about 20 layers, 25 layers of the PCB board. But in AI server, because the data is too fast, because the complexity is too high, now we are talking about 40 layers or even higher layers of the PCB composition. It's not about only stacking to the multiple different times of the structure, but it's about that bring some of the critical technical challenge for the reliability and for the whole completeness of the whole process. Zeiss solution is helping the PCB maker, which is our customer, to look into the composition from layer to layers of the bonding or the stacking, detailedly analyzing what is the problem inside of this composition. We have our very, very proud electronics microscopy solutions, can do the material analysis, can do the dicing, can do all the way of the different methodology to see what is the problem inside of the PCB board. This is definitely not an extension of the material sciences, but it's about a methodology of improving the process of the PCB making. While we have identified the issue from the failure analysis lab by our electronics microscopy, we were turning back to the process in improving the whole methodology of the manufacturing and the design for sure. So PCB's issue is not only happen on the bonding and the stacking, but also it's a very complicated three-dimension structure the signal is not only like horizontally transmitting from component to component. Also, they have a vertical way to transmitting the data. I think the audiences here, you are all the experts. However, we want to say is, if the channel from the board to different boards, they have a problem. If the position is not correct, if all the issue that happen makes the resistance is not accurate as what we measure or we design in the very beginning, what will happen? They will bring noise. They will bring a lot of the uncertain of the signals, of the vibrance and some of the interruptions. This is not what we want, because this is the machine to really transmitting the high speed and high frequency data. Zeiss machine, with the non-destructive of the weight, can look inside of the board from different layers to check whether there's any problem from those data transmissions, no matter it's the blind hole, no matter the through hole, all this process, you will be get covered by the Zeiss technology. But the most important thing is not about those hole that inside of the board. The traditional way to inspecting the PCB inside is actually we do the section. I still remember when I talking to one of the customers, they say nowadays one board of the price is actually almost 70 times of the price than the consumer electronics age. It means that if you are going to do the failure analysis check or the IPQC check, the in-process quality check, you need to spend 70 times of the cost to making sure your board is correct. But guess what? If you can use in a non-destructive way to look inside, you don't need to chop in the board, you don't need to destroy the board, but you can directly look inside of the board and figure out what is the problem. I think the slide that we are showing here is what we so-called the technology of the stop length, the back drill. The back drill technology is actually the super big headache in the whole industry right now for the quality. We have a lot of story that are working with our customer together to improving this back drill, I would say, process, and using our machine to look inside of the back drill. And the most important dimension, which is what we so-call the stop length, need to be very, very precise under the spec. And when we looking around all the devices and the solution provider, Zeiss is the only solution provider can fulfill the precision level for the customer need. This is actually the very, very typical cases about very straightforward issue and a very straightforward solution. They need to have a higher resolution, and we provide the highest resolution solution. If the pin is losing, what will happen if the pin is not on the right position? What if the pin, when you just connect from the male side and the female side, and they just not matching? And I can tell you, everybody, you hear a lot of the noises when they are talking about the new generation of the AI server platform. Oh, they meet some of the quality challenge, and they actually get some of the hurdles for the mass production. This is one of the hurdles. Thanks for the Zeiss technology, we see a very great industrial CT solution can put the high-speed connector inside of our chamber to look about where is the problem and why it caused the failure. Again, without chopping the connector out or destroy it. We can keep the scene, and we can making sure what is the real issue in that scene causing the data transmission problem. Connector is for sure very important, but I would say this is maybe the hottest topic that in this AI server industry. We are talking about the cooling technology from air cooling to liquid cooling. Another interesting story that last year when Zeiss joined the Computex, we hear our customers say, Clive, do you know, if we have a one leakage cooling problem, one tip of the leakage, it causing 3 million of the rack get destroyed, get broken. This year, we hear the similar story. However, the cost of the poor quality increasing from 3 million to 7 million. It means that if you don't have the right liquid cooling solution, if your quality control get a problem, sorry, 7 million is gone. That's the reason Zeiss has now really working together with majority of the tier 1 of the supplier to no matter NVIDIA or AMD of the platform to giving them the highest quality of the solution for the thermal solution. This is actually not so, I would say, stranger to everybody. It's a microchannel one. Based on the microchannel fins, they increase in the volume of the surface to bring out the heat away. However, when you are doing this kind of the, I would say, precise assembly, and when you want to attach in and put the cold plate on the surface of the IC, you definitely need to put some glue adhesive solution over there. Once those glue and adhesive solution, they stuck in the middle of the fin, what will happen? That will decreasing and they will discounting the thermal performance. This is what we can do toward into this kind of the very, very advanced type of the microchannel cold plate. Then we can see where's the problem. Whether there's any contamination, whether there's any design fault to making the efficiency is not good as the design. That's actually the Zeiss solution can provide. And then finally, back to the story, we are talking about from chip to rack. Rack is the final, I would say, defensive line over there to making sure the quality is okay before they really deliver to the data center. But rack, maybe people were asking about how bad can that be? It's a rack, just a rack. It's an enclosure, like a shelf, right? If you do buy a like shelf from IKEA, you don't need to making sure that it's a super high quality. However, in the AI server industry, that's a big problem. Because you can imagine every single unit of the AI server, the weights adding up together will crushing and changing the deformation of the rack. What does that mean? It means that we need to have a very, very clear design over there with a certain shape of the rack and wait until we put maybe 24, 27 of the different units inside of the rack. And then we're naturally causing the change of the shape back to the real triangle. Can you imagine that? It's actually, we get it from the end design and the end product of the prediction, reverse it back if we don't have those very heavy units, and what should be the shape looks like in the very beginning. So that will be not a very easy triangle over there in the very beginning. So we need to have our solution effectively to see what is the problem or what is the difference from the design to the end product, which is the rack. We honestly have been really see a lot of issue and the problem about the deformation makes the unit of the AI server cannot be really put in and the insert into the rack. That's a little bit hard to imagine, right? It's actually, oh, this just put it inside. However, this deformation really bring out a lot of the issues. We talk about the overall solution and the issue from the chip to the rack level. But if we're talking about some of the new stuff here, it's Zeiss' responsibility to helping keeping improving the quality. I want to invite my colleague Tomoe back to talking about on the chip side, what's the new technology trend looks like and how we solve it.
Thank you, Clive. Well, it's quite fascinating how we are ensuring quality from chip to rack, right? But those are applications that we face today. What about the challenges of tomorrow? Well, let's talk about one of them. Let's start with high bandwidth memory. I think everyone knows about HBM. This is talked about so much in newspapers, articles, everywhere. So everyone tries to maximize the output from an advanced package. For a high bandwidth memory, you do that by stacking multiple layers through a TSV. This is called through silicon vias. What happens at that micro scale, as you stack 16 stacks, you get an impact called warpage. It bends. Okay, so how do you fix that? So a lot of our customers are looking at not silicon, but looking at glass as a substrate. Well, glass is brilliant. It won't warp. You can stack over it, low power consumption, and high connectivity. But glass, it's a nightmare for microscopy. Yeah, the contrast is not there. So if you really wanted to get to glass, we have to find imaging techniques so that we can find defects in the glass. And this is exactly what we are working on. We are going to enable our customers moving on to glass substrate in order to get the next generation packages. Yeah, and that's what's coming up.
Not only on the chip side, CPO. I know you guys are very, very interested about this new technology. Once we're talking about the new technology, it brings the new challenge at the quality side. We are talking about transmitting the optical data to the electricity data, but what is carry those optical data? The fiber. How detailed and how precise of our mechanical and the platform should be to really accurately not make the signal getting loose and successfully transmitting the optical data. We've been working with our customer for some of the very, very detailed and the precise of the mechanical parts over there, just become the enclosure and then the loading platform to transmitting optical data. A lot of details we really want to say, but we cannot say here. But I can guarantee you that will require the most, I would say, advanced technology to look inside of the design, no matter from the housing, no matter from the tooling, no matter from every single angle of the mechanical design should be fitting to the criteria. Very good technology and a very, very challenging quality topic.
Of course it is.
So, we now talking about from chip to PCB. To the thermal solution, remember, 1 dip of the leakage, 7 million. To the rack of the deformation, connectors transmitting all the data, optical interconnection, OCP, and the power solutions. This is what ZEISS providing from the quality perspective. This is the second year for ZEISS join the Computex. And we are the only one quality supplier in this industry to join the Computex and is showing the most advanced solution. This is our honor because we also see some competition this year in the show. We are happy to see that because this is the trend and it shows people and our customers they are seeing the quality as a more and more important topic.
Yeah, and we truly believe that we want to enable the future of AI, and we're working with partners in order to orchestrate that quality, because quality just doesn't matter for the enabling AI, but quality matters for the economics of this industry. Quality is directly equal to billions of dollars that drives this industry forward. And we are committed to working with partners to solve the most challenging quality problems of today and of tomorrow. Thank you.
Thank you, everybody. Okay.
Yeah.
Okay. Thank you.
感谢 Mr. Tamoy Kandu 和 Mr. Clive Yan 精彩的分享。